Of this 16, 9 are on the first string. So 9 on the first string, and then 7 and 7 in parallel on the second string. That's the configuration. So right now we've got 9 operating and 7. So 9 on one string and 7 on the other. We're just finishing up the second 7, which will parallel with the first 7 that are in operation. I'll show you on the junction box where that's occurring. So here's the first combiner box. This is what we're using for the first 9 that are in series. So you can see we used a lightning suppressor, a delta, rated for the voltage that we're operating on. I think this is good to 600 volts. Okay, so you could see that since it's a single string, we have a single fuse. That is, I think I'm using 10 amp fuse here. And then inside, you could see that we have coming in from the serial solar panels, or these pigtails. One of them comes to the negative, which is here. The other one comes to the positive, which is here. Goes out to a bus bar. And then this is our power out on the red wire. That's what's going into the inverter. So that goes down into the inverter, as does this black wire goes to the inverter. And then the ground wire goes to the inverter. Of course, the ground wire comes up and bonds to this lug, which is attached to the conduit. And then the lightning suppressor, the ground hooks up to the ground bus bar, positive hooks up to the positive bus bar up there, and the negative hooks up to the negative bus bar that you see there. And then that is basically the connections that we're using. And I was mistaken. This black is actually for the lightning suppressor, and this white wire is our negative terminal. So we have much of the same in the other junction box, but that's going to be the parallel connection junction. Another thing important to note is the grounding. So we have grounding lugs attached to the rails, attached to every panel. So both rails are grounded and all panels are grounded. So that ground comes into the junction box, into that terminal, and this bare copper wire, we've run it to the top rail, to every panel on the top. And then down here, we come and bond it to the other bottom rail. So the bottom rail is all bonded, and also on every joint that connects the rails, we're using a metal bonding bar that cuts into the rail and makes connection to the rail. Here, though, this is interesting. We're using this to float because the rail is greater than 23 feet long. So this side isn't bolted in. This will allow any thermal expansion, but we still have ground bond occurring here. Same thing's happening down on the bottom in another location, which is over there, because they're not exactly the same, symmetric top to bottom, the rails. We use aluminum strut from Copper State as the back support. So you can see how we have it to the roof mounts, roof jacks, and then just use an angle up here to do the connection to the rail, the top rail. The bottom rail is directly connected, and we use 2 L's to get ability to angle that bottom rail. So this is a junction box to get the 7 panels that are on this string here connected to the junction box that you could see is going this way. So on the back side of this, these are actually the 3 panels, 2 and 2 make the other 7. So 7 from that string comes into this junction box right over here. And then this is a parallel combiner. And then the other 7 we're working on right now getting connected. So these are 3, and these are going to get tied in this junction box with the other 4. The other solar panels you see here are on a pike inverter, a separate system. So this is our junction box that we're working on right now, trying to get the 2 panels over here to feed this junction box, which will connect them to the other 2 panels in series. So they'll have 4 panels in series. Those 4 panels in series will go back down to this, will come all to here. So we'll have those 7 in series, and then we'll put them and connect them to the other 7 panels, and it'll be a parallel connection. So 7 in series, 7 in series, and then they're parallel together, and then those run down to the inverter for the second string. As you see, we also have a lightning suppressor on this pair of 7 panels in parallel. And then these are the specs of the panels. And I want to talk a little bit about the mounting. We're using the mid-mount clamps. Everything we got from all the rails and all the hardware, mostly we got from eSolar Warehouse online. So these are the end rail clamps. These are the standard rails. These are the gray boots to cover the ends. They sold us this cover. I'll show you one that hasn't been sealed, but we added fiberglass mesh to it, and then we rolled it with Tucson rubberized coating. You can see the 3.5-inch standoff, and then the L brackets. In the back, in some areas, because the roof, the elevation pitch of the roof, we actually used double standoffs. Here, it's not a double standoff, but I'll show you that as we go down the line. But you can see we used their clips to hold the wiring in. We used their ground lugs. We used their mounts. This is what bolts the rails. And then, I don't think you can see it, but on every backside of a joint we also used you see that? That's the grounding. And so these little screws here pierce into the rail, break the anodized coating, and make an electrical connection to bond the rails to each other. It's more of a detailed view of the L bracket. And then the rubber caps keep the rainwater from coming in, and these are screwed in 2 spots with big lag bolts to the beams or joists that run in this direction on our roof. Okay, so I don't see any double standoffs here, but what we did when we had to get a little bit extra height, and we probably could have bought their 8-inch or a little bit longer standoff, but since we had the 3.5s, we just screwed them to each other using a stud. I think we had to tap a couple of them. You could see right there where we joined them to get the height we need. And this is the shield cover, the water shield cover before we add the rubberized coating. And then, so we used 2 Midnight Solar boxes, and the rest of the boxes are just standard junction boxes. I could probably share with you the dimensions, but you just want enough room to work. So right now I have to get some of these pigtails, bring it to Luis, and he's going to do the connection on those 2 panels into the junction box. Okay, you can see I've got these glands that should seal against the box. Sorry, I don't know if you can see them right there. But we're going to put these wires in and then get them into the box. Sorry guys, it took more force than I could do by just do with one hand. So this is now pushed in, and we're going to make the connections. We're going to be using what are called Polaris connectors, or they're a type of Polaris connector to do the junction bonding here. For now though, I'm going to get all these wires connected so they're ready to connect right there. So you can see they're messy right now, but I'm going to start working on the wire management, and we'll get them going. Alright, so we cleaned up the wiring here. We got this panel connected here. I'm going to use tie wraps to hold this. Now you can see these little clamps beneath it to adjust it, and now I'm going to get these tie wrapped and then connected into the box, and then we'll do the connection to take these to the other junction box that Luis is working on right now. So I'm going to do the wiring connections here. Tie wraps. Okay, so we got the wires all bundled up. We've got the connections. So these two panels here are connected, and they bring their positive and negative over to this junction, which is for the next two panels. The negative from that other string, we're continuing on to the string of 3, as you see here. Then we are taking the most positive from the first set of 2 panels, which is this wire here, and we're getting it out and going to hook it up to the negative, the most negative of this string. Then the most positive of this string we'll plug in here and continue. It'll come into here and continue out to this next set of 3. So 2 plus 2 plus 3 is 7. So we'll have 7 in series. So this is a junction box, which is the combiner box for the 7 we're working on and the 7 that we previously had installed. It's going to put them in parallel, which you see here. It goes to a common bus bar, and then that goes out to input on the inverter. So what we have here is the most positive coming from now the string of 4 gets hooked up to this black wire, which comes through here, and it's this one here. So this being the most positive hooks up to the most negative of the string of 3, and then the most positive of this string of 3 comes back in, and it becomes our absolutely most positive connection. So when we measure from here to here, we should get about 250 volts. Alright, so here's the junction box. It's actually the trickiest junction box because it's got 3 connections. And then again, we showed you this already, but this is the other junction box. So working on the last one. Once he gets all these connections done, we will be able to test it. We'll have 2 strings of 7 in parallel, plus another string of 9 on input 1 of the inverter, and these will be on input 2 of the inverter. So right now you can see we're just working on arranging the breakers so the pressure is not so high, but you know, we used 10 gauge on each of these, and then it came to 6 gauge as it went out.